Alright, so we have number 16. Well, this one's going to be 16 through, I'm going to expand it a little bit through 32, because those are all 30, 31, and 32 all kind of go with this together, so we'll expand it a little bit here. But 16 says lithium iodide. Well, lithium is a metal, and again, check this to make sure that you know how to tell the difference. Iodine is a nonmetal. And so since I have both, this is an ionic compound. Number 17, we have iron cobalt. Both of those are metals, so this becomes a metallic compound. Number 18, what group is tin in? Well, tin is right here on our periodic table, so we look up, and it is in 4A. This is number 18 again. Number 19, what is electronegativity? It is a measure of how strongly an atom pulls on electrons. Okay, what are number 20 then feeds off of this? What are the two main reasons for this? Size. The bigger, the worse the electronegativity. Kind of like if I have our sun, okay, we're going to attribute gravity being a little bit like the attraction between protons and electrons. And then I have the planets are like our rings that we draw, right? This green one is going to be pulled much less than this blue one will be. So the bigger, the less pull it has, so the less electronegative it is. The second reason is the number of protons. Okay, so if I have lots of protons and I'm very small, I have a high electronegativity. This one is secondary to this one. Okay, your size is the big key thing. The number of protons is secondary. So if we look at that on the periodic table, this is doing number 21 and 22. I go this way gives me more protons. This way gives me less size. Noble gases don't count because they don't bond. So fluorine is my most electronegative element. And the closer you are to fluorine, the more electronegative you are. So you could say like barium would be 1, ruthenium would be 2, silicon would be 3, oxygen would be 4, listing 4 elements in order of increasing electronegativity. Up to fluorine being the most electronegative. So that's 21 and 22 right there. All right, 23. Where are the nonmetals located on the periodic table? We already looked at that in the previous one, but just so that for a quick refresh, we draw our line here. Anything touching that line is a metalloid, which we're not really concerned about what they are or what they do. We just need to know that they are there. These are my nonmetals with hydrogen, and everything else is my metals. Okay, metals and non-metals. The characteristics of a metallic bond, we listed that one day. They are conductive. Metal is always conductive. It conducts electricity and heat very well. They're malleable. You can bend them into any shape that you want to, a car or a desk or whatever, a statue. They're ductile. I can make wire out of them. And they have a sea of electrons. They don't really hold onto their electrons at all. Characteristics of a covalent bond then, which is 25, not 24. They are non-conductive. They will never conduct electricity. Remember, we did the lab. Sugar did not ever conduct. They are discrete. They have separate units. They usually don't dissolve in water, or they dissolve poorly in water. Hopefully you saw with that lab that the sugar took longer to dissolve than the salt did. They tend to be flammable and have a low boiling point and low melting point. Okay, and we melted the sugar to prove that. 26, what are the characteristics of an ionic bond? It is conductive. It has a metal, so it is conductive if it is a liquid or dissolved in a liquid. Okay, it has a lattice, which is that whole calcium oxide, calcium oxide, calcium oxide. It isn't CaO, it's this whole big long block. It has a very high boiling point and melting point. Remember, we couldn't ever get it to melt. And it is brittle. It breaks. That was the weirdest bee I think I've ever drawn in my life. Very easily. Chalk breaks very easily. Salt breaks very easily. Okay. 27. What happens to the electrons when a metal and a non-metal bond? Well, we have, let's say, KO. Okay, this is a non-metal. Let's change colors here. That's a non-metal. This is a metal. The metal has this one electron. Oxygen wants 2 electrons. It has 6. Right? It wants this electron to jump over here and fill that one spot. It'll need 2 of them eventually, but it'll take the one. So when a nonmetal, which is very strong, very electronegative, is placed with a metal, which is a wuss, it takes that electron away and we get charges. So we have K plus and right now O minus. And eventually it'll still another one and become 2 minus, but with what it has right here it can only become 1 minus. Okay? So that's what happens when they get together. Number 28, what happens to the electrons when a metal and a metal bond? Well, neither of them really want it. I've got iron here, I've got iron here, they've got these electrons, and they just kind of let them start floating around in the sea of electrons. So I've just got iron cores with their electrons floating around. This is why it's so easy to conduct electricity through, because it just goes right through all of these electrons here in a metal. Okay, number 29 through 32. I'm going to set up this whole problem and then go back to answer this individual parts. We're going to take 67.90 grams of zinc fluoride, 2 atoms of fluorine. So we have 67.90 grams of zinc fluoride. All right. We add those together from our periodic table. Zinc has 65.39 and fluorine is 19.00. So we add all those together. We got 103.39 grams of zinc fluoride. And remember to keep with your units in 1 mole of zinc fluoride. Then we're going to go to compounds, and I know that this is a compound because it's a metal and a nonmetal. Anytime that there's a metal, it's a compound. So in 1 mole of zinc fluoride, I have 6.02 e to the 23 compounds of zinc fluoride. And in 1 compound of zinc fluoride, I have 2 moles, or 2 atoms, sorry, of fluorine. Okay, so look at each of those individual steps. Make sure that you can follow your table on that, and you know where you're getting all of those numbers from. So the first question, question number 29, asks how many sig figs are in this number? Well, I have my 6, my 7, my 9, and my 0. My 0 counts because it's at the end and there is a decimal, so I have 4 sig figs in this number. Okay, my next one says how many moles, so I'm just going to go to here, and that, when I calculated it out, is going to be 0.6567 moles of zinc fluoride. So my next one wants to know how many compounds, so I'm going to go to here and stop. So I'm going to times this number by the 6.02 to the 23rd, and I'm going to reduce my sig figs down to 3. So it's going to be 3.96 e to the 23rd compounds of zinc fluoride. And then the last one wants me to go all the way to atoms of fluorine, so I'm going to times it by 2 now. And so I'll go 7.92 e to the 24th. Nope, still 23rd, sorry, still 23rd. Atoms of fluorine. Alright, so that gets me through to number 32, and we will go on to the next one and finish up with that one.